Good morning, everybody. Welcome to math class. Good afternoon if you're here for my afternoon session. Today we are learning counting. Let's start off with the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. We're going to take a quick look at this week. On Monday, you should have watched the recording of our circle graphs lesson from last Thursday. And yesterday, you should have watched the recording on our probability basics lesson from Friday. Both of these lessons have homework that are due on Sunday, the 23rd. Today, we are learning counting. We're also going to look at Venn diagrams. And this homework will be due on the 30th. Let's do a quick review from our last lesson. The following chips are placed in a bucket: 4 red, 1 yellow, 5 blue, and 1 green. One chip is randomly selected from the bucket. What is the probability that the chip is blue? Take a moment to answer this question. The probability that this chip is blue is 5 over 11. We solve this by taking our total possible outcomes, or adding all of them up. 4 plus 1 plus 5 plus 1 is 11. There's 11 possible chips we could pick. Then we take our favorable outcome, in this case, the blue chips. There are 5 blue chips, so our probability of getting a blue chip is 5 out of 11. We're going to conduct an experiment and make a chart to record all of our possible outcomes. I have 2 nickels. I'm going to flip each nickel and record if I get heads or tails. On the table, I'll put a T for tails and an H for heads. One option that I have when flipping my coins are heads for nickel 1 and tails for nickel 2. Another option I have is tails for nickel 1 and heads for nickel 2. I also have the option of getting tails on both nickels. And finally, I have the option of getting heads on both nickels. What is the probability of tossing 2 heads? Take a moment to answer this question. Out of our 4 different combinations, we had 1 opportunity of getting heads twice. So our probability of tossing 2 heads is 1/4, 1 out of 4, or 25%. What is the probability of tossing 2 tails? Take a moment to answer this question. The probability of tossing 2 tails is also 1 out of 4, or 25%. Finally, what is the probability of tossing 1 head and 1 tail? Take a moment to answer this question. Our probability here is 2 out of 4, or if we reduce that, we can say 1/2. We had 2 different chances out of 4 of having one of our nickels land on heads and one of our nickels land on tails. This is a 50% probability. We just used a table to organize our data, but we can also use a Venn diagram to organize our data. You may have seen Venn diagrams in English. Venn diagrams use 2 or more circles to compare different items. In each circle, you have a separate item, and where those circles overlap is where you have things that those items have in common. Let's try one. We have the numbers 1 through 20. One of our circles says odd numbers, and our other circle is labeled numbers greater than 10. Where they overlap, we would put numbers that are greater than 10 and odd. Go ahead and draw this on your paper and take a moment to fill it in. If we look at our answer key here, we can see that our odd numbers are 1, 3, 5, 7, and 9. We can see that our numbers greater than 10 are 12, 14, 16, 18, and 20. Where our circles overlap, we can see we have numbers that they have in common. 11, 13, 15, 17, and 19 are all odd numbers, and they're also greater than 10. You'll notice at the bottom of our Venn diagram here, outside of these circles, are the numbers 2, 4, 6, 8, and 10. These numbers couldn't fit inside any of our circles because they are less than 10 and they are even. but we have to still include them on the outside of the Venn diagram because they are still pieces of our data. Let's try another one. Naomi made this Venn diagram to show the types of shoes displayed in a store window. How many pairs of shoes are black with laces? Please take a moment to answer this question. We can see that there are 2 pairs of shoes that are black with laces because in the overlapping of our circle, we have 2 data values. What do the dots on the outside of this Venn diagram represent? Just like we had numbers outside of our Venn diagram when we displayed the odd numbers and the numbers greater than 20, we have data points outside of this Venn diagram. So that means that these shoes are neither black nor do they have laces. Maybe they're brown or blue or green, all without laces. Quick check here. The circles represent these characteristics of a group of movies: comedy, less than 90 minutes long, and rated G. How many movies are less than 90 minutes long and rated G? Please take a moment to answer this question. We can see that we have 2 movies that are 90 minutes long and rated G. Here we have 3 circles that are overlapping. So there's 3 overlaps in the middle that include 2 circles and 1 in the very center that actually means all 3 are coming together. If we look at just the 2 circles that include less than 90 minutes and rated G, where they overlap, there are 2 data points. How many people play all 3 sports? Please take a moment to answer this question. We can see our answer here is 0. If you look at the circle where all 3 circles overlap, you can see that we have no data values there. So our answer is actually 0. Let's talk a little bit about possible outcomes, and let's look at some tree diagrams. Our question says, a family has 3 children of different ages. How many outcomes of their birth order are possible? Well, a tree diagram helps us figure out all of our possible outcomes. We're going to start with our oldest child. We know that our oldest child has the opportunity to be a boy or a girl. So we have 2 options. From there, off of each of those options, we're going to put the next options for our middle child. The middle child, again, can be a boy or a girl. So coming off of our original oldest child, we have 2 branches, 1 for boy and 1 for girl. Then coming off of each middle child option, we have 2 branches again. Our youngest child can also be a boy or a girl. Then we can list our possible outcomes by following each branch. Boy, boy, boy gives us BBB. Boy, boy, girl gives us boy, boy, girl. Boy, girl, boy gives us boy, girl, boy. And boy, girl, girl would give us the option of boy, girl, girl. We can do the same for all of our girl options as the oldest. Go ahead and take a moment to see how many possible outcomes are there. We can see that we have 8 total possible outcomes for these 3 children. All you need to do to figure out how many total possible outcomes you have are count up the outcomes at the end. So let's try one. Al is playing a game that uses 2 spinners. The first spinner has 3 colors, and the second spinner has 3 numbers. How many possible combinations are there? First thing I'm going to do is fill in the color. I'm going to start with red. So I can have the color red and the number 1. That would give me the combination of red 1. I'm going continue working with the same color. So now I can have red, number 2. So my next combination would be red 2. Continue working through this chart until you filled in all of the possible combinations you can come up with. Let's take a look. You should have gotten red 3, yellow 1, yellow 2, yellow 3, and blue 1, blue 2, and blue 3. Now we have hit all 3 possible colors and all 3 possible numbers in every combination possible. Question number 1. How many combinations include blue or yellow? Take a moment to answer this question. If you go through and count, there were 3 combinations that included blue and 3 combinations that included yellow, for a total of 6 combinations. Question number 2. How many combinations include an odd number? Take a moment to answer this question. If we go through and take a look, we can see that there were 3 that included the number 1 and 3 that included the number 3, for a total of 6 combinations. Let's work on another tree diagram. Here we have animals, sizes, and age. We have dog, small, and younger, which gave us the combination DSY. Let's fill in the next combination. We have dog, small, older. So our answer here would be DSO. Our next combination is dog, large, younger. Here I would fill in DLY because now we've moved on to large dogs. Moving down into the cats, our first blank here is cat, small, younger. So I'm going to fill in CSY for cat, small, and younger. Our older cat is filled in there, so let's move on to the large cats. Cat, large, younger would give us CLY, and cat, large, older would give us CLO. How many combinations include older animals for adoption? Take a moment to answer this question. We can see that there were 4 total combinations that included older animals for adoption: a small dog, a large dog, a small cat, or a large cat. If you have any questions on today's lesson, please feel free to send me an email and I will answer it as soon as possible. You guys did an awesome job. I can't wait to get back from PSSAs and get back in the classroom with you. Your homework tonight is counting. You're going to see very similar questions to what we did in class today. You will find this homework in the Quarter 4 Part 1 folder, and this homework is not due until Sunday, April 30th. Have a great rest of your day.